principles and techniques that we have to cover up here. So let's start discussing about that. Before starting with the same, it's a huge request to all the viewers. Please go ahead, like, share and subscribe so that many and maximum people can get information. We have learned some of the questions in the last class of 38. Today we want to start discussing about the structural representation of organic compound. So let's get started here. Structure, representation of organic compound. In this first wants to complete condensed bond line structure formulas. So let's go for the same. Where the Lewis structures or dot structure, dash structure, condensed structure and bond length structure formulas are some of the specific types here. Where the Lewis structure, however, that can be simplified by representing the two electron covalent and bond by dash, and so a structure formula focuses on the electron evolved in bond formation. A single dash representations of a single bond, double bond, dash, and is used for the double bond, and a triple dash representing the triple bond, and that lone pair of electrons of heteroatoms, that is oxygen, nitrogen, sulfur, halogen atom, that is etc., that has been shown thus ethene C2H6, ethene C2H4, ethyne C2H2 and the methanol CH2OH can be represented by the following structure formulas. Such structure representation is called complete structure. So let's write it out for the same as well. That is your ethane and ethyne, and of course methanol. So let's go for the structure sequence. First we go for first one, that is your ethane, where we have 2 carbon atoms here and then we have 5 hydrogen atoms. So this is your ethane. So here there is single bond, and now another one is your carbon double bond with carbon, and then we have your hydrogen. This is your ethane. Now coming towards ethyne, carbon double triple bond with carbon, and then we have 2 hydrogen atom attached to a carbon atom. This is your ethyne. Now we go for the other one, that is your methanol. That comes under unit carbon dash with oxygen atom with 3 lone pair bonded with hydrogen, or we can say that carbon bond first. So one methanol. Okay. Towards coming these structures or formula that can be observed and abbreviated by indented sum of all the dashes representing the boron bonds, and by indicating the numbers of individual groups that attach to an atom by a certain step. The resulting expressions of the compound is called a condensed structural formula. That is called the condensed, and this is for your complete. Now we talk about for the condensed. So for that condensed here, that the resulting expression of the compound is called condensed structural formula. Thus ethane, ethyl, ethyne and methanol that can be written. क्योंकि complete के form में है, complete structural representations of an organic compound that we have. Now we'll talk about for the condensed here. So let's go for the same. And for the condensed here, which we have your first we talk about ethane, that is CH3CH3. This is ethane. Another we have for ethene, which is CH2, double bond CH2, that is your for ethene. Another is ethyne, carbon triple bond with carbon that is attached with, of course, your hydrogen, which is CH, that has been written. Okay, and this is your ethene, that is ethyne. For the methanol, it will be CH3OH. So that is your methanol. Now coming towards with another one, and I'm going to discuss about some similarities and that we have as follows here as well. Let's go for the same. For that similarities, that similarly CH3, CH2, CH and CH2, 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 CH3 can be written in the form of condensed CH3, CH2, 6, CH3. Therefore, for the simplification, the organic chemistry used another way of representing the structures in which only lines are used, and in this bond line structure, representations of organic compound, carbon and hydrogen atom that are not shown, and the lines are representing the carbon-carbon bonds that are drawn in a zigzag fashion. The only atom this is specifically written as oxygen, chlorine, nitrogen, etc. The terminals denote methyl group unless indicated otherwise. They denoted by carbon atom bonded with appropriate number of hydrogens required to satisfy the valency of the carbon atoms. Some of the examples that are being presented here as follows. Let's go for the same, and that is as follows here. So for the methyl, that is methyl octane, that can be represented in the various form. So we'll go for one by one. So we'll talk about first, it is your first we talk about this 3-methyl octane, that can be represented in the various form. The first we talk about here, A form that will do is your CH3, CH2, CH, CH2, 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 CH3. And this is CH is your CH3. The first form we will be having representing here. Second form we can represent here as well is CH3 bond with CH2 bond with CH bond CH2 CH2 bond with CH2 CH2 CH3, and this is single bond with CH3. Now talking about the third one, which will be going or you can also represent 3-methyl octane is as follows. So for the first one, this is terminals represent methyl group. these were the terminals. Okay. Understood. So now we go for another one, that is about another question, and that what we have discussed here as well. So we will be going for the various ways of representing the 2-bromobutane, and that we have as follows as well. So various ways of representing the 2-bromobutane that are as follows. So here we go. The first one we will be representing here CH3, CH, Br, CH2, CH3. Second is CH3, CH, CH2, CH2, and for the CH that has been linked with bromine. So that has been representing your 2-bromobutane, because there are butane is your, there are the 4 carbon 1, 2, 3, 4, and 2 is bromo is at position of carbon 2. That is being representing as your 2-bromobutane. That will be going for the next one, and that is of course the third one that we will be representing here is as follows, which is here it is being bromo. Okay, this is the third representation. Now we go for the next one. In a cyclic compound, that the bond lines forms that will be given as follows. So let's go for the same. So with the same, when we are going for the further one, and that we'll discuss about it. So here in cyclic compounds, the bond line formulas given as, so first we representing your cyclopropane, so that has been represented here as first, that is your CH3, CH2 bond with CH2, this is bond with CH2. So all are bonded with your CH2, that the bondation has been taken from the carbon-carbon atom as well. This is your cyclopropane. That can be represented as you can see here, this is being forming a triangle. Okay, now we go for the next one. This is cyclopentane. This is for cyclopropane. Now we talk about cyclopentane here, that is your being as follows, which is being CH2. This carbon atom has been bonded with CH2, another one. This is being bonded with CH2, CH2, this is bonded with CH2, that is of course bonded with the carbon atom, the another carbon atom. This is known as cyclopentane. Okay. And for that cyclopentane that has been representing here, as you can see, it has been representing like forming a pentane. Now we go for chlorocyclohexane, and that has been representing here with the chlorine atom that has been attached to it. So we go for it CH2, CH, Cl, CH2, 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 and that has been bonding here. So this is all reversing we will go for another one that is called the chlorocyclohexane. So this is the cyclohexane. Okay, now we'll go for the questions here, and that is very important about this. So there we have your multiple questions that we have to talk about it, but we discuss one by one so that it will be helpful for you, and then we'll discuss about the three-dimensional presentations of organic molecules as well, so which is very of course important one, and that we will discuss about one by one. So with the same we go for it. Here we go with the first question. That the question we have related to it as well. The question is, expand each of the following condensed formulas into the complete structural formula. The first we have CH3CH2CO, CH2CH3. The another one is CH3CH, double bond CH, CH2 thrice, and CH3. So let's go for the same, and if you are able to solve it out, you can just solve by your side. It will be helpful for you. If you are not able to, I will be providing you the solution as well, and you can just go for it and you can find the solution there. Let's go for the same. So here we go for the same, and that is the question is the fourth question of this particular unit, which is organic chemistry with some basic principles and technique. So let's go for the same. So the question fourth we have, the question is, expand each of the following condensed each of the following condensed formulas into their complete structural formulas. So the first one we have CH3, CH2, CO, CH2, CH3. The presentation is one side, and the second then we have your another one. We will do one by one. CH3, CH, double bond CH, CH2 thrice, and CH3. Okay, so we will do one by one, and that will of course helpful for us as well. So here we go for the same. For the first one, that you can see here is carbon bond with carbon, bond with carbon, with carbon, with carbon. So that we have, this is CH3, then CH, 2H, then double bond with O, carbon, hydrogen, secondary CH, and then of course here we have your CH3. Okay, so this is your the complete structural formulas that will be in the condensed form, and that will be going for the complete structural formula. But then another one is CH3, CH double bond CH, CH2 thrice, CH3. So let's go for the same here. Let's go for the same. So here see carbon, which is CH3. So we go for reattaching with the 3 hydrogen atom here. Then it will be connected to CH, double bond with carbon, CH, and we have carbon CH2, carbon CH2. Then we have carbon CH2. Then we have carbon CH3. Okay, so this is the formula that we have to discuss here. Now we go for the next one with the next question, and that is the question is, for each of the following compounds, write the condensed formula and also their online formulas. So without wasting time, we'll go for it. We'll of course do it with the condensed and of course the online formula. So one by one we will be going for the same. So here we go. First we go for the questions here, and that we have as follows. The question is, this is the fifth question. For each of the following compounds, write a condensed formula and also their bond line formula. Let me go for the one by one. First one is H2CH2, CH2, CH2, CH, CH3, CH, then we have CH3 and CH3. Okay, so for this, first we go for the condensed formula. So condensed formula, that is your CH2 tri-CH, CH3, CH, CH3 whole twice. This is the condensed formula. One line formula, let's go for the same. That is your OH bonded titanium. Now we go for the next one. That is the another formula, and that is your as follows: is your N triple bond carbon bond CH bond OH bond C triple bond N. So we go for first one, that is your condensed formula. The another one is your bond line formula. Okay, so for that it will be your condensed formula that will be representing here is HOCH CN twice, and for the bond line formula it will be OH bond with CN. Okay, this is what we have. So here we're going to end up with this, and we'll discuss the rest in the next summit class, which is your 40th class, and we'll start discussing about the questions, of course. That is another question. After that, we will be going for the next one, the next topic that what we have to discuss. So here, stay tuned with us, and please like, share, and subscribe so that many and maximum people can get the information at once, and whenever you can also enjoy the videos. So stay tuned for